Hello everyone, welcome to HBL, our very first in the year. So today, as the HBL should be seamless, right? So we are in class, we are just going to start this new chapter, chapter 2 stats. So this will be what we're going to do for HBL this time round. So this is the new chapter, so we will learn a few new things, a few new terms like all the quartiles and the interquartile range. Is something new. You will learn to read a new so-called diagram. It's called box and whiskers. And then you will learn to calculate mean, median, quota for discrete data set. That means when the number is 1 by 1. But the focus here is odd and even numbers of terms. So when the number of terms they give you is an odd number versus an even number is slightly different. Okay. After that, with the numbers, no matter odd or even, you will learn how to draw the box and whiskers diagram. So this is the basic, the part that we're going to do today. So before we start, just a quick recap of all of Sec 2 things. So the term average, always when you see the word average, we always think of mean. But strictly speaking, in the mathematical concept, all these three are considered averages. Just like we use this and think about averages the most with the mean. Okay, so for the mean, the actual word called mean, it is the so-called all the numbers. Let's say these are the numbers, all add together, divide by the number of terms. So 1, 2, 3, 4, 5, 6, 7. So divide by 7. They all add together. I note as a mistake because I wrote 14 and in the working I put 13. So actually it's wrong. So please make the adjustment. Okay, then for the median, we all remember is the center term, right? The one in the middle. But what you will need to remember is the data need to be sorted. So sorted in this case means ascending order. So from the small to big. Okay, then since there are 7 terms, it's going to be this one, the 4th term, because there's 3 here, 3 here. So right in the middle is 10. Okay, so 10. After that, mode is the one that happens the most often. In this case, there's only happens to be only one number that's repeated. So this is the most often, so it's 11. Then the last thing we're going to learn is a recap is the range. The range is not really an average, but we ask this quite often, so might as well put it here. So range is just biggest minus the smallest. In this case, it will be 14 minus the 2, so there will be 12. So that's the recap of all the Sec 2 stuff. Okay, the next thing we're going to talk about is this new thing called interquartile range. Okay, so what is this interquartile range? We basically divide the numbers or the data into 4 different parts, which will correspond to 25%, 50%, 75%, and the 100% mark. Okay, so in this interquartile range, in this case means I take the Q3 minus the Q1, so the 75% minus the 25%. Now what does this do? This eliminates all the outliers. So if I take 75% minus the 25%, I'm taking anything that's between 25 and 75, which means I'm throwing away the 75 to 100 and the 25 to 0. So the 2 extreme ends I'm removing from the data set, so to speak. Because why? Because the outliers are always the extremely small, extremely big. So I want to just throw them away because most of the people are in the middle. Okay, just like an exam, you have very little with like 95 and above. So these are the 95 and above. You have also a very small handful with like maybe from 10 to 15, but they affect the average quite a lot. So when we remove them, the bulk of the so-called normal people are here, and we are interested in that range. Okay, so that's the long story of what we're doing. Okay, so now you need to scan this QR code, and this video will show you how to calculate the mean, the Q1, Q3, and the interquartile range, blah blah blah, all these things when it's odd and even. There's a slight difference. You need to know this difference very well. Okay, I'm not going to go through this one. You please own self-scan, settle yourself. Okay, after you have done this, you can actually I'll go through one of the example. I'll go through this example. So if you haven't watched the QR code, this may not make too much sense to you, so you must well go and watch it now. Okay, so in this question we're going to go through just this one we won't do. So you can see that there are 20 questions taken by 8 students. So all these numbers represent the 8 students, how many questions they get correct. Okay, So we're supposed to find the Q1, Q2, Q3 range in the quota range, right? So we need to find all these things. But our first step is to sort the data from small to big. You notice a lot of this marking here. So what I was doing was, I look at for the smallest, 9. I write 9, I put a tick on top. After that, I look for the next smallest, I put a tick on top, I write down, so that I do not miss out any terms. Because if you make a mistake, you're finished, right? So of course, after that, I go and count how many terms, and make sure it tallies. It should be 8, because they say 8 students. So 1, 2, 3, 4, 5, 6, 7, 8. After that, I'm going to do what we just learned in the QR code. 8 student is even, so it's going to be 4, 4, median. After that, cover, middle again. After that, cover, middle again. So just within 5 seconds, I got my Q1, Q2, Q3 done. Okay, so Q1, Q2, Q3. Range will just be biggest minus smallest, done. In the quota range, Q3 minus Q1, this minus this, done. So that's it. Very simple. Okay, the next part, we're going to introduce this box and whiskers diagram. Again, it looks a little weird, but once you know how to read this, it becomes a very fast thing. Box and whiskers diagram is like a representation of a diagram representation of the number. So that's one look, you know roughly what kind of data we are looking at. So you can see that there's 2 extreme ends here. So this will be the smallest number, 10, biggest number, 80. And what's this box here? This box, the left side of the box represent the number for Q1. The middle with the line, it's not always in the middle, but there will be a line inside the box. This is the median, Q2. And of course, you can guess this must be the Q3. So based on this, I can say that the Q1 and the Q3 is pretty compact. That means most of the people are within this 42 to 57. Okay, and the median is 49. But we do have some outliers, because see, such a big distance is only 25% of the people, and it's quite far away from the Q1. Same thing, there's also some outlier here. The higher end is also quite far away from the Q3. Again, this part only got 25% of the people, but it's such a far distance away. Okay, so again, these are big outliers. So just by looking at the diagram, we know roughly what the data is like. So same thing, once you understand what all the numbers are, you can simply just calculate the normal thing. So if I want, let's say, range is biggest minus smallest. If I want in the quota range is Q3 minus Q1. Exactly the same. It's nothing much. Okay, so I'm just going to go through just one example. You notice the biggest difference is that in this question, I'm given in a grid. That means a graph paper kind of a grid, right? The only reason they give you graph paper is because they want it to be accurate, meaning you literally can read off the data as if it is a graph question. Okay, so for all graph question, one of the good practice is figuring out one little box is representing how many, because if you don't write this at the side, you have a lot of things to think about when you look at the numbers. It's better to just think about it and be clear. So how I do this is that from 90 to 100, there are 5 boxes here, right? Which means by law of common sense, one little box represents 2. And I'm going to write this down so that if I need to refer, I need to think, I don't need to think so hard. I just look at, one box, how many? So from there, it's quite easy. Okay, so let's start. So they say state the median. So now we all know that the median is the line in between, right? So this must be the median, 60. Okay, done. So easy, right? After that, range. So again, the range will be the biggest number. In this case, is 100. The smallest number is 20. So it's 100 minus 20. Yay, done. Next one, in the quota range. So in the quota range will be this number and this number. So okay, now you look, it's a bit tricky. So it's like half a box like that. I'm going to zoom this a bit more so you can see it clearly. Let's do this one. I think this is easier. So this is 80 plus one more box, which is 2, right? So it's 82. So the Q3 will be 82. Now let's come to this one. It is 30 plus half a box. So half a box refer to 1. So the Q1 will be 31. So of course in the quota range will be this minus this lah. Done. So it's just reading, the graph paper only, is no big deal. So with this, I'm not going to go through the second question. I'm just going to just show. I'm just going to show the median because we need the median. The rest you do yourself, okay? So again, you're given 2 smartphone, 2 box and whiskers, blah blah blah. You're going to count all things. Eventually, you notice they ask you, what brand of the smartphone has a longer lifespan on average? Now, this is the first time you are asked to compare things or make a maybe make a comment. So how we do this is either we are using the median or the interquota range. You will see more questions in the future, but median usually is used to measure who is better, who is faster, who lasts longer, that kind of thing. Whereas interquota range sort of describes the spread of the data. So if the interquota range is big, that means my 25 to 75% is quite a big number of people, or has a big range. A big range. So it's not so compact. So a bigger interquota range usually means the data is quite spread out. It's not very compact one. Everybody is quite far from each other. So that's how you compare. So different context, different. But you must know that it's always either compare median or compare interquota range. And the answer will be always like that. Smartphone B is in this case longer lifespan because median is higher, full stop. Okay, so it's along this line. It's quite simple one. Okay, so the next part we're going to do is you should have guessed it. From the diagram you can find the numbers. Now I give you the numbers, you must draw the diagram for me. You notice in this question I never give you the graph paper to draw, so you don't need to be pinpoint accurate. But if I give you the graph paper to draw, it needs to be drawn extremely accurately, so the scale must be all correct. Okay, so what I do is clearly this is data, right? A lot of data, and then I counted, there's 12, so I put a mark here. Okay, I've got 12 numbers, I better go and count later. Then I'm going to sort from small to big. So again, you notice I do the dot, right? As I write a number down, I check it off so that I don't miss any numbers. Then in this case 12, right? So it's 6, so it's 1 2 3 4 5 6. So this is one half, this is the other half. So from here I find the Q1, Q2, Q3. Okay, so for here is the same thing, but I have extra working here, so I want to point out to you. So after I got the Q1, Q2, Q3, notice what I'm doing here. I'm writing likely a curly bracket 12, curly bracket 9, 7.5, 4.5. What is this for? This is to give me a sense of where is further. So for example, the extreme end is 61, Q1 is 78. So it's 12 numbers difference. And then same thing for Q1 to Q2 is about 9 numbers difference, and so on. So what I'm trying to see is the distance between the Q1, Q2, Q3 and the extreme ends should be reasonably proportionate. Okay, so since 12 is the biggest, this gap, when I drew it, I make sure it is the biggest, right? Then within the box, one side is 7.5, one side is 9. So I make sure the left one is a bit bigger, because this is from Q1 to Q2, it needs to be 9. So bigger than this, but smaller than this, so something like that. So the last one is the same, 4.5. So it needs to be the smallest among these 3 gaps. So clearly it's the smallest. Okay, so once you settle this gap, you just draw the line below and you just mark the various numbers. So that's one of the tricks I use when I'm forced to draw a box and whiskers diagram, which is not very common, but sometimes you still need to draw. Okay, so after that, you see that the next question, instead of giving you the numbers straight in your face like that, they actually give it to you in an indirect way. This is our stem and leaf you learn in Sec 2, right? So in this case, just a refresher. Like that, 19/4 means what? 194. So this is 191, 194, 195, and so on. Now, a lot of people are thinking, okay, I'm going to list out all the numbers from smallest to biggest. But let's not be silly here. There's so many numbers to write. We're lazy people, right? So we should not do that. So it's already sorted, if you didn't realize. It's sorted like this. Here, 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 here. So this data is already sorted. It is unnecessary for you to write down all the numbers again. We got better things to do. So I counted, okay, total got 20 terms here. In my mind is 10, 10. Alright, 20 ma. So the Q2 is going to be the number 10th number and the number 11th number divided by 2. Then after that, for the once I get the median, so the left side is still left with 10 because it's even number, right? So for here, I'm going to take the 5th and the 6th plus together divided by 2 because there's 10 terms in total, so it's 5, 5, so it's 5th and 6th. In the same theory, 15 and 16 term and then divide by 2. Okay, so I'm just going to demonstrate one. Okay, so in this case, 10th and 11. So how do I get the 10th term? So from here, this is the smallest, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be 208. So 208. After that is the 11th term. So that will be, so this is the 10. So the 11th one is here. So that will be 210. So 210. After that, divide by 2. Done. So that's how you extract all the numbers. There's no need to write all the numbers out again. Okay, so after this, of course, the smallest one is very obvious. So it's 191. Biggest one is 228. So here. After that, what you notice is I actually write down all that 5 numbers. So this is the smallest, biggest, Q1, Q2, Q3. I counted already. And then again, I do the calculation of the gaps. So what I do is I see that I'm going to draw the rectangle for just any rectangle. And I see that, okay, 7.5, 8.5. So that means the left side's gap needs to be slightly smaller. So I just find the middle, I shifted a bit left. So this is a bit smaller than this. Okay. After that, I realized in this case, it happens to be 10.5, 10.5. That means these two gaps need to be the exact same number. So I just anyhow draw one. I use my ruler to measure. For my case, it's about 1.8 cm. So here I also draw 1.8 cm. And then I just draw the line at the end and I label the number accordingly. So that's how you draw the box and whiskers diagram. So since so that's the end of what we're going to cover. So when we come back to class, we're going to start with the part 2, the continuous data. So since we have already covered the first part, I need to highly recommend, in fact I want to insist that everybody, you should start doing the homework 1, because that covers the first part. Now look, let's be honest here, it's only like what, 4 questions. Come on, this is, I don't think it will take even half an hour. So let's quickly do this so that we can get on with the next part where the real questions, the longer questions really are. Okay, so hope you have learned something good. Thank you and have a good HBL. Bye bye.